Alright, so the last section that we are going to do this week, 6.4, parametric equations. Okay, so first off we need to know what a plane curve is. Basically a plane curve is a set of points x and y, so on the rectangular plane, such that x equals f of t and y equals g of t. And f and g are both continuous on a set interval. We'll call that interval I guess. Okay? And the equations x equals f of t and y equals g of t are parametric equations with a perimeter t. So what are parametric equations with a perimeter t? They are x equals f of t and y equals g of t. So the one example that we're going to focus on looks like this. Alright, so this says graph x equals t squared and y equals 2t plus 3 for negative 3, 3. So this right here, the negative 3, 3, is they're basically telling us what our input is in both of these equations. And you can obviously see that the input in both of these equations are the t's. So this is telling us the interval for t. Alright, so we're going to sketch this by hand and then check it by using a calculator. And then the second part, we're going to find the equivalent rectangular equations of these two, because right now these are parametric equations with parameter of t. So even though they look like a rectangular equation because they have x and y, they're not really because of the t. Okay? Now, this is a lot easier than you might think. Basically, what we're going to do to graph this, we're going to make an x and y table. Alright? Now, this side of the table is for the x. So it's for this equation. So we're going to get the x. And for here, we're going to plug in to get our y. And to get our y, we're going to plug into this equation, so 2t plus 3. And then our input in both of these was t. Alright, so t is our input, and they gave us a parameter, they gave us an interval for t. They told us that t has to be between negative 3 and 3. So that means that I'm only going to input variables within that interval. So negative 3, negative 2, negative 1, 0, 1, 2, 3. And therefore I'm going to find my x's and my y's. So let's plug it in. So negative 3, you plug it in, negative 3 squared is 9. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Sorry, this was supposed to be a 3. 3 squared is 9. Alright? And then for our y, for our y's, for our y coordinates, we're going to plug in 2 times negative 3, which is negative 6, plus 3. So that's going to be negative 3. 2 times negative 2 plus 3 is negative 1. And we're going to plug in the rest, and we end up with 1, 3, 5, 7, and 9. Alright, and now I'm basically going to graph these guys as my x and y points. Alright, so we're kind of going back a little bit to basic algebra. So here's my x and y axes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right, so let's graph these. So when we graph them, 9, negative 3. So I'm going to go out to 9. I'm going to go down to negative 3. That's approximately right there. 4, negative 1, 1, 2, 3, 4, negative 1, 1, 1, 0, 3, 1, 5, 4, 7, and then 9, 9. Now here is the key. So you notice the graph. I'm going to connect the dots to graph it. Obviously, does not keep going on forever and ever, left or right, because we have a set interval, and that set interval was given to us by our inputs. We do have to show that our interval, actually, that our graph, that we started graphing at this point, this was the initial interval, and that I graphed this way. Okay, so that way I'm showing basically that my interval was from, started off our points down here, and then we graphed up. Okay, so that's all it is for that first section. And you can check it using a calculator, but we'll do that together in class on the TI. Now the second part, find the equivalent rectangular equation. So the equivalent rectangular equation. Alright, so now basically what we want to do is we want to get rid of the t, because rectangular equation is an equation that only contains x's and y's. So what that means, here are my two equations. Y equals 2t plus 3, and x equals t squared. Now I'm going to start with this equation, and I'm going to solve for t. And the reason I'm starting with this one is this is going to give me a more unique solution than this. If I just plug that in, I'm going to end up with just a square root of x, and plugging that back in here is just going to give me an uglier answer. So plugging in, using this one to begin with, I'm going to solve for t. So we're going to solve for t. So first thing we do, we subtract 3, and then divide by 2. So t is equal to y minus 3 over 2. And now if you remember back from substitution, I take what I just got here, and I plug it in to the second equation. For t. Now t is equal to this, so that's going to go into the second equation. So now we're going to end up with x equals, instead of t is this now. So I'm going to plug in y minus 3 divided by 2. And of course, don't forget the squared, because this equation was originally t squared. So now, basically I can simplify this just a little bit, right? So I'm gonna distribute that squared to the top portion and the bottom portion just to make it look a little bit nicer. So we end up with y minus 3 squared. Now you notice I didn't distribute it to the 3 and the y because there's a minus here, but I can distribute it to the whole top and the whole bottom because it's division. And then that is divided by 2 squared, which is 4. Alright? And then it'd look a lot neater if we just pulled out the 1/4 to the side and called this 1/4 y minus 3 squared. So my final answer is x equals 1/4 y minus 3 squared. Alright? And then basically my y interval was between, y is in, if you remember from here, -3 to 9. And even just by looking at the graph, you notice that the range is from -3 all the way up to 9. And then my domain was from 0 all the way to 9. And that is it for this section. So really, it's just going to be using the equations, plugging and graphing, and then using substitution to get it into one equation. Alright, but this is called a parametric equation because of the t.